We present ViGather, an inclusive virtual conferencing system with a joint experience across traditional screen devices and mixed reality headsets. Virtual reality has the potential to substantially advance teleconferencing as we know it. Modern VR headsets allow users to communicate through voice, natural gestures, and eye contact much like in real-world face-to-face meetings. However, current teleconferencing systems integrate users on screen devices such as laptops or tablets to a diminished degree. These users appear on plain 2D screens in the virtual environment, which considerably limits participants' perceived physical presence. Therefore, users calling in from non-immersive devices ensure a curtailed experience similar to remotely joining a real-world meeting. We introduce ViGather, a system that jointly represents all participants in the same immersive experience. On non-immersive devices such as desktops and laptops, ViGather integrates state-of-the-art technology to recognize the 3D skeleton of a screen device user and map it to a virtual avatar, rendering experiences where screen device users are indistinguishable from VR users. At the core of our system is a reconstruction pipeline that allows screen device users to join virtual meetings as avatars. Using the Media Pipe Post API, we can process a monocular video stream from the front-facing camera of a screen device to get the 3D positions of the head and hand landmarks, as well as the orientation estimates of the individual joints. In case the hands are outside the view of the camera, we complement the reported tracking cues to ensure continuous avatar motions. Using Meta's Avatar SDK, we then animate the skeleton as an avatar and render it in the virtual meeting. In VR, we utilize the Oculus SDK to reconstruct head and hand poses using the video feed from the headset's built-in cameras and again use Meta's Avatar SDK for rendering. To enable a joint experience among VR and screen device users, our system also implements a server-client architecture. A relay server exchanges audio and motion data between clients, allowing them to synchronously render local environments of the same virtual meeting room. In our user study with 16 participants in groups of 4, we compared ViGather with Meta's Horizon teleconferencing in 2 tasks in which participants had to brainstorm ideas for movies or businesses. In Meta's Horizon, screen device users view the virtual environment on one section of their screen while seeing themselves and other screen device users in separate views. In VR, they are represented on a large display rather than as avatars. Using ViGather, participants reported a higher sense of physical, spatial, and self-presence while using screen devices compared to Horizon. To better understand how the coherent representation of screen device and VR users affects the user experience, we conducted a second user study. Thus, we compared ViGather with a VR meeting application that only differed in how screen device users were portrayed within the virtual environment. The results confirmed the significance of representing screen users as reconstructed avatars for enhancing their sense of self-presence. Taken together, our findings suggest that screen device users benefit from being represented as controllable virtual avatars and having a first-person view of the virtual environment. In summary, ViGather demonstrates a truly immersive teleconferencing system that integrates users in a joint virtual meeting experience, no matter where they are or what device they use.